welcome to for today's class. Today we will deal with solutions and colligative properties. Solutions and colligative properties. What are the main topics to be discussed under this chapter? The main colligative properties. So basically this chapter can be divided into two parts. One part is concentration terms, other part is colligative properties. What are the concentration terms? What is the usefulness of the concentration term? So concentration terms are used to know the relative quantities of the solute and solvent present in the solution. What are the major concentration terms? Weight by volume percentage, weight by weight percentage, molarity, molality, normality, mole fraction. These are the concentration terms. And what are the colligative properties? What do you mean by colligative properties? The properties which depend upon the number of the particles are called colligative properties. What are the colligative properties we have under our syllabus? RLVP, relative lowering of vapor pressure, which is related to the Raoult's law of vapor pressure. Next, elevation of the boiling point, and depression in the freezing point, and osmotic pressure. These are the topics which we have to discuss today. Now we shall give more emphasis on the colligative properties today. Why we are giving more emphasis to the colligative properties today? Because these concentration terms, discussion about these concentration terms will be mixed with the colligative properties. After all, colligative properties are based on the concentration terms only. What are the concentration terms that are useful in the calculation of the RLVP? Molality and mole fraction. And for the calculation of the elevation in a boiling point and depression in the freezing point, what is the major concentration term? We are using molality. And regarding the osmotic pressure, we use molarity. So discussion about the concentration terms will also be carried along with this colligative properties. Now, in discussing the colligative properties, what is the first? RLVP, relative lowering of vapor pressure. So RLVP is equal to RLVP at a given temperature. RLVP will be equal to X1. What is meant by X1? Mole fraction of the solute. Next, elevation in the boiling point, elevation in the I into X1. Elevation in the boiling point is given by the expression I into Kb into m, and depression in the freezing point is given by the expression I into Kf into m. Osmotic pressure is calculated by using the relation. Osmotic pressure is represented by pi is equal to ICRT. What is meant by I? Van Hoff's factor. So the value of Van Hoff's factor becomes significant only in case of the electrolytes. For non-electrolytes, Van Hoff's factor will be equal to 1. Now we will discuss what is meant by Van Hoff's factor and what is the relation between the Van Hoff's factor and the degree of dissociation. Suppose in case if the electrolyte undergoes dissociation, the electrolyte undergoes dissociation, the electrolyte undergoes dissociation, alpha is equal to I minus 1 by n minus 1. What is alpha? Degree of dissociation. What is I? Van Hoff factor. What is n? Number of particles formed due to the dissociation of 1 mole of the electrolyte. In case of the association, alpha value will be equal to I minus 1 by n minus 1. 1 by n minus 1. If the electrolyte undergoes association, then this is the way, this is the relation between alpha value and I value. So basically by definition, what is I value? What is I value? Final number of the particles, final number of the particles by initial number of the particles, final number of the particles by initial number of the particles, or experimentally observed colligative property, by theoretical colligative property, because colligative property always depends upon the number of the particles, or in case of the molecular weight, theoretical molecular weight by observed molecular weight, because colligative property is inversely proportional to the molecular weight. So this is briefly about our discussion. Now we will go ahead with the discussion of the numericals. Through numericals we will try to explain the concept. Now the first question is 6 grams of urea is dissolved in 90 grams of boiling water. The vapor pressure of the solution is, this question is related to the relative lowering of vapor pressures. This question is related to the relative lowering of vapor pressure. So by definition, what is the statement of the Raoult's law? Relative lowering of vapor pressure is equal to mole fraction. Relative lowering of the vapor pressure is equal to mole fraction. So what is the relative lowering of vapor pressure? P naught minus Ps by P naught is equal to x1. x1 is equal to n1 by n1 plus n2. n1 plus n2. What is x1 stands for? Mole fraction of the solute. n1 stands for number of moles of the solute. n2 stands for number of moles of the solvent. In the denominator term, n1 can be neglected. If n1 number of moles of the solute taken is negligible. But in this case 6 grams of urea means 0.1 mole. So 90 grams of water means 5 moles. So when compared with 5 moles, 0.1 mole need not be neglected. So what is the P naught value? What is the temperature? Boiling water means what is the temperature maintained at 100 degrees centigrade? P naught value will be equal to 760. Minus Ps by 760 will be equal to 6 by 60 by 6 by 60 plus 90 by 18. So solving we get the value of the Ps. We will get the vapor pressure of the solution. This is the procedure. Why I have not neglected the N1 value? Because N1 value is 0.1. What is the N2 value? 5. So to get the maximum accuracy, let us not neglect it. When compared with 5, 0.1 need not be neglected. Next question. At 20 degrees centigrade, the vapor pressure of diethyl ether is 442 mm when 6.4 grams of non-volatile solute is dissolved in 50 grams of ether. The vapor pressure falls to 410 mm. What is the molecular weight of the solute? So simple, P naught minus Ps by P naught is equal to x1. What is the reduced form of the Raoult's law? W1 by M1 into M2 by W2. What is W1? Weight of the solute. What is W2? Weight of the solvent. M1 is the molecular weight of the solute. M2 is the molecular weight of the solvent. Now, what are the things? 6.4 grams of the now what is the P naught value? 442. 442 minus 410 by 442 is equal to, what is W1 value? 6.4. 6.4 by M1. M1 we have to find what is the M2 diethyl ether C4H10O. So 48, 58, 74, molecular weight of ether is 74 by W2 50 grams. Solving will get the value of M1. So option 2. Option 2 is the answer. Is this simple arithmetical similar calculation here. Next problem. The relative lowering of vapor pressure of 0.2 molar solution in which the solvent is benzene. Now, by definition, by the Raoult's law statement, RLVP is equal to x1. RLVP is equal to x1. RLVP is equal to x1. Now, how to find x1 value when molality is given? When molality is given, x1 is equal to molality by m plus 1000 by m2. What is m stands for? What is m stands for? Molality of the solution. What is by m2 stands for? Molecular weight of the solvent. What is x1? What is x1? x1 is equal to n1 by n1 plus n2. n1 plus n2. When molality is given, what is the definition of the molality? Number of moles of the solute in 1 kg of the solvent. So, N1 is taken as M, and how to calculate the N2? Weight of the solvent by molecular weight of the solvent. What is the weight of the solvent when molality is given? 1000 grams by M2. So, 0.2 by 0.2 plus 1000 by, what is the solvent here? Benzene. What is the solvent here? Benzene. So, solving will get the answer as option 2 is the answer. Next. Vapor pressure of an aqueous solution is 2% less than that of the solvent. What is the molality of the solution? What is the molality of the solution? Now, in this case, how to find the molality of the solution? So, RLVP is equal to x1. RLVP is equal to x1. From the x1 value, we can find the molality. What is the molality when mole fraction values are known? Molality is equal to x1 into x1 by x2 by 1000 by m2. What is x1 stands for? Mole fraction of the solute. X2 stands for mole fraction of the solvent. M2 stands for molecular weight of the solvent. So, this is the way. Now, they want us to find the molality. Now, we have to first find x1. How to get x1? RLVP is equal to P naught minus Ps by P naught. Now, what is the Ps value? 2% less than that of the pure solvent. If P naught is 100, Ps will be 98 by P naught. So, 2 by 100 x1. This is equal to x1. What will be the x2 value? X2 value will be 98 by 100. So x1 by x2 is equal to 1 by 49. 1 by 49. And what is the solvent here? Aqueous solution. So 1000 by m2 is equal to 1000 by 18, which is equal to 55.5. Therefore, molality will be equal to 55.5 by 49. It comes around 1.13. Option 3 is the answer. This is the way to find the molality. So RLVP is equal to x1. RLVP is equal to x1. When mole fraction value is known, this is the way to calculate the molality. When molality value is known, how to calculate the x1 value? M by m plus 1000 by m2. These two relations are very important in the calculation of RLVP values. Please remember this. Next question. The amount of glucose to be dissolved in water so as to produce the same lowering of the vapor pressure, delta P is proportional to the lowering of vapor pressure is given by the delta P. Delta P is proportional to the concentration. Delta P is proportional to the concentration. If delta P values are similar, if delta P1 is equal to delta P2, what does it imply? The concentrations of both these solutions are equal. Concentrations of both these solutions are equal. This is the point to be remembered. When delta P, lowering of the vapor pressure, is due to the dissolution of the solute. When delta P values are same, it can be taken for granted that concentrations of both these solutions are equal. Now the glucose, the lowering of vapor pressure of the glucose solution is same as that of 0.2 molar aqueous solution. So from this, the molality of glucose solution is also can be taken as molality of glucose solution can also be taken as 0.2. What is the expression for molality? W1 by M1 into 1000 by W2 in grams. What is W1 stands for? Weight of the solute. M1 molecular weight of the solute. W2 weight of the solvent. Now what is the molality? 0.2. This is to be found out. W1, this is 180 and 1000 by what is the weight of the solvent? 500. So W1 must be 18 grams. This is the concept. Only one step. Next question. A current of dry air is first passed through the solution through the bulb containing solution A in water and then through this bulb containing through the pure water. The loss of mass in the solution, bulb, is proportional to PS. What is PS? Vapor pressure of the solution. The loss of mass in the solvent bulb, is proportional to P naught minus PS. What is the total loss? In mass. Is proportional to P naught value. Total loss in mass, if you add both, will get P naught. So, loss in mass in the solution, loss in mass in the solvent bulb is proportional to P naught minus Ps. Total loss in mass is proportional to P naught. Now, what is the way? Mole fraction. How do you get mole fraction? P naught minus Ps by P naught is equal to x1. So, P naught minus Ps means loss of the mass in a solvent bulb. What is the loss of mass in the solvent bulb? 0.08. What is the total loss in the mass? Total loss in the mass is 0.08 plus 1.92. The answer comes to 0.04. So, option 4 is the answer. Next, these are the important points to be remembered. The next question. An aqueous solution containing 1 gram of urea boils at 100.25 degrees centigrade. The aqueous solution of containing 3 grams of glucose in the same volume will boil at, so boil elevation in the boiling point, is proportional to delta B, for delta TB is equal to I into Kb into M. Since both happen to be non-electrolytes, I is equal to 1 and Kb is constant, delta TB is proportional to the molality. Now, what is delta TB1? 0.25. Delta TB1, TB2, delta TB2 is equal to, what is the 1 by 60? 1 by 60. Number of moles of the urea is 1 by 60. Number of moles of the glucose is 3 by 180. Since number of moles are same, so delta TB2 is also equal to 0.25. So, what will be the boiling point? T naught B plus delta TB 100 plus 0.25. 100.25 because number of moles are same, volume is the same. Next, a solution is prepared by dissolving 0.8 grams of naphthalene in 100 grams of CCl4 has a boiling point elevation of 0.4. So, what is the expression for both happen to be the non-electrolytes. So, delta TB is invariably proportional to the molality. Delta TB1 by delta TB2 is equal to molality of the first solution by molality of the second solution. Molality of the first solution by molality of the second solution. What is delta TB1? 0.4. What is delta TB2? 0. Elevation of 0.4. What is delta TB2? 0.62. What is the way to calculate the molality? 0.8 grams of naphthalene, 0.8 by, what is the molecular weight of the naphthalene? 128 into 1000 by 100. Now, what is the amount? 1.24 by molecular weight into 1000 by 100. So, solving the molecular weight of the second salt is also equal to be 128. because elevation in the boiling point is certainly proportional to the molality of the solution. Next question. Molality of an aqueous solution that produces an elevation in the boiling point of 1 Kelvin at 1 atmosphere pressure, kb of water is given as 0.512. Assuming that the solution is the solute is non-electrolyte, delta Tb is equal to kb into m. So m is equal to delta Tb by kb. Delta Tb is 1 and this is equal to 0.512. Approximately nearly it will be equal to 2. In the given is 1.95. Option 3 is the answer. Option 3 is the answer. Next question. So this model we have done already anyhow. So P naught minus P is equal to loss in the mass of the solvent bulb. What is the loss in the mass of the solvent bulb? Loss in the mass of the solvent bulb containing 0.03. P naught minus Ps by P naught is equal to W1 by M1 into M2 by W2. Making proper substitution, we will get the answer. So P naught minus P is corresponds to the loss in the mass of the solvent bulb, which is given as 0.03. What is the total loss, the total gain in the mass of the CaCl2 bulb? It is 2. What is the weight of the solvent? Weight of the solute that is dissolved? 30 grams. 30 by 200. And what is the 200 grams of water finally through a solution? What is the molecular weight? W1 by M1, 30 by, here we have to give the molecular weight. And what is the 18 by 200? Solving, will get M1 is equal to 180. Option 1 is the answer. Next. So here what is the point? Delta TF is equal to I into KF into M. Here which are constant? KF is constant, molality is a constant. So delta TF is proportional to the I value. So assuming the complete ionization of the sodium chloride and sodium sulfate, for urea I is equal to 1, for sodium chloride I is equal to 2, for sodium sulfate I is equal to 3. So what will be the ratio of the depression in the freezing points? 1:2:3, because what is I? Final number of the particles by initial number of the particles. Assuming the complete dissociation of the strong electrolytes such as NaCl and Na2SO4. For NaCl I is equal to 2, for Na2SO4 I is equal to 3. So the ratio is 1:2:3. Next question. At 10 degrees centigrade, osmotic pressure of the urea solution was found to be 500 mm. The solution is diluted x times and the temperature is raised to 25 degrees centigrade. Then the atmospheric pressure was found to be 102.3 mm. Then what is the dilution effect? The x value means how many times? What do you mean by x? X is the times of the dilution. So at the same temperatures, at a same, so pi is equal to ICRT, pi is equal to ICRT, pi is equal to ICRT. For urea, I is equal to 1, for urea I is equal to 1. So pi is equal to CRT, pi 1 by pi 2 is equal to C1 T1 by C2 T2, because R gets cancelled out. What is the pi 1 value? 500. What is pi 1 value? 500. What is pi 2 value? 102.3. 102.3. 102.3. 102.3. 105. 105. And what is this C1? What is T1? What is it? T1. What is T1? 283. What is C2? What is T2? 298. 298. So by making calculations, the ratio of C1 is to C2 will be 5. That is, the solution is diluted by 5 times. The solution got diluted by 5 times. So the ratio is 5. C1 by C2 is equal to 5. So x value will be 5. X value is 5. The solution got diluted by how many times? 5 times. A 5% solution of cane sugar is isotonic with 0.5% of X. What should be the molecular weight of the substance? What should be the molecular weight of the substance? Generally, what do you mean by isotonic? Solutions having the same osmotic pressure values will be considered isotonic. Pi is equal to ICRT. For cane sugar, I is equal to 1. When the temperature is kept constant, pi is proportional to C. Pi 1 by pi 2 is equal to C1 by C2, that is equal to 1. So C1 is equal to C2. Now let us come to the, what do you mean by 5% solution? 5 grams of the solution, 5 grams of the cane sugar is in 100 ml of the solution. 5 by 342 into 1000 by 100. In this case, 0.5 by molecular weight into 1000 by 100. Therefore, molecular weight of the solute will be equal to 34.2. This is isotonic, means pi 1 is equal to pi 2. So the ratio constant when temperature is kept constant, R is constant, then pi is proportional to C. This is the way to calculate. Next question. The osmotic pressure obtained by mixing 200 cc of 2% solution of urea with 200 cc of the 3.42% solution of the sucrose at the same temperature, that is 20 degrees centigrade. We can apply Dalton's law of partial pressures for this solution. So pi of the mixture pi of the mixture will be equal to pi 1 V1 plus pi 2 V2 by volume of the mixture. Now what is V1? 200. And what is V2? V2 is also 200. What will be the volume of the mixture? 400. So pi of the mixture, osmotic pressure of the mixture will be equal to pi 1 plus pi 2 by 2. Now what is the value of pi 1? 2% of the solution of the urea. Pi 1 is equal to 2% means 2 grams of the solute is dissolved in 100 ml. 100,000 by 100 into R 0.0821 into what is temperature? 293. What will be the pi 2? 3.42 by 342 into 100 by 1000 by 100 into 0.0821 into 293. This is the way to calculate the pi 1 and pi 2. And what will be the pi mixture? Pi 1 plus pi 2 by 2, which comes around 5.2 bar. If you simplify this calculation. Next. Now coming to this, a decimolar solution of K4FeCN6 at 300 Kelvin is 50% dissociated. Then what will be the osmotic pressure of the solution? Pi is equal to ICRT. But how to find the I value? Relation between I value and alpha value is given as alpha is equal to I minus 1 by n minus 1, or alpha is equal to I minus 1 by n minus 1. What is the alpha value? 0.5. What is I? We don't know. I minus 1. When K4FeCN6, when 1 mole of K4FeCN6 is dissolved in the water, how many moles of ions will be produced? 5 moles. 4K plus 1 ferrocyanide. 5 moles. 5 minus 1. So I minus 1 is equal to 2. I is equal to 3. Now making proper substitution. So what will be the pi value? So I is equal to 3 and concentration is 0.1. R is equal to 0.0821. And what is the temperature maintained? 300. It must be around 7.38. Option 2 is the answer. Van House factor for 0.01 molar aqueous solution of acetic acid is 1.04. What is the pH of that solution? Now, how to get for the pH of the acetic acid is supposed to be the weak acid. Therefore, H plus ion concentration will be equal to C into alpha. What is the C value? 0.01. Now we don't know the alpha value. To find the alpha value, alpha is equal to I minus 1 by n minus 1. So when 1 mole of acetic acid is dissociates, we get 2 moles. Therefore n is equal to 1. So alpha is equal to I minus 1. 1.04 minus 1, it is 0.04. Alpha is equal to 0.04. Now what is the H plus ion concentration? C into alpha. What is C? 0.01. What is alpha? 0.04. It comes to 4 into 10 to the power minus 4. And what will be the pH value? 4 minus log 4. 4 minus log 4. It will be 3.4. So option 1 is the answer. So to calculate the pH value, what must be known? H plus on. For a weak acid, H plus on concentration is equal to C alpha. We know the Ci value. We have calculated alpha value as this, and finally pH value is 3.4. Next. The vapor pressure of the mixture of 0.1 mole of the liquid. This is an example for Rolle's law for a mixture of two miscible liquids. For a mixture of two miscible liquids, what is the Rolle's law expression for a mixture of two volatile liquids? P total is equal to Pa plus Pb. Pa plus Pb, where Pa will be equal to partial pressure due to A will be equal to P naught A XA, and Pb will be equal to P naught B XB. P naught B XB. In this case, we have to develop two equations. Initially, 1 mole of liquid A, 3 moles of liquid B are present. Then what will be the mole fractions of XA? 1 by 4, and because the initial mole ratio Na is to Nb is equal to 1:3. Then what is the mole fraction of A? 1 by 4. And what is the mole fraction of the B? 3 by 4. So what is the first expression? First expression 0.25 into P naught A plus 0.75 into P naught B. P naught B is equal to 550 mm, because P total is equal to Pa plus Pb. What is Pa? P naught A into XA. What is Pb? P naught into XB. What is XA? 1 by 4. What is XB? 3 by 4. That is 0.25 P naught A plus 0.75 P naught B. Its value is 550 mm. Now what was done? When 1 mole of liquid B is further added, then what will be the mole ratio? Na is to Nb will be equal to 1:4. Then mole fractions will be Xa will be equal to 1 by 5, Xb will be equal to 4 by 5. Then another equation can be generated. How another equation can be generated? 0.2 into P naught A plus 0.8 into P naught B will be equal to, by 5, by the vapor pressure increases by 10 mm, so 560 mm. This is equation 2, this is equation 1. When we solve these equations, we get the P naught A value as 400, P naught B value as 600. When we solve equation 1 and equation 2, we get the P naught A value as 400 mm and P naught B value as 600 mm. So here what we have done, we have generated two equations. This is a special case of Rolle's law for a mixture of two volatile liquids. Next question. The vapor pressure of pure benzene and toluene are 160 torr and 60 torr respectively. Mole fraction of the benzene in vapor phase in contact with the equimolar solutions of benzene and toluene. So vapor pressure, mole fraction in the vapor phase, generally mole fraction in the vapor phase vapor phase is denoted by Ya, which will be equal to Pa by P total. Pa by P total. So where Pa is equal to P naught A XA and P total is equal to P naught A XA plus P naught B XB. P naught B XB. So Ya is equal to, what is Ya stands for? Mole fraction in the vapor phase is equal to P naught A XA by P naught A XA plus P naught B XB. So what is the XA and XB value? Equimolar ratio. Mole ratio is 1:1, then mole fractions will be equal to 1/2, 1/2. Now what is the P naught A? 160 into 1/2, 160 into 1/2, 160 into 1/2 plus 60 into 1/2, 60 into 1/2. So Ya is equal to 80 by, here 80 plus 30, 110, 8 by 11. So it comes to around 0.73. Next question. Here the solubility, this is a problem based on Henry's law. This is a problem based on Henry's law. In Henry's law, the solubility is directly proportional to the partial pressures. Since the gas is same and Henry's constant is also the same. Temperature is the same. Next, 1 second. The solubility at the pressure. So S1 by S2 will be equal to P1 by P2. S1 by S2 will be equal to P1 by P2. What is the S1? What is the S1? 5.3 into 10 to the power minus 4. We have to find the S2. What is the pressure 1 given? 593. What is pressure 2 given? 760. Solving, we get the S2 value as 4.1 into 10 to the power minus 4. 4.1 into 10 to the power minus 4. Sorry, 6.8 into 10 to the power minus 4, because it increases slightly. Next question. So mole fraction, if the mole fraction of A in this solution, if it obeys Rolle's law, simple, P naught minus PS by P naught is equal to X1. Initially is 40 minus 32. 40. For initial, what is the initial pressure? Vapor pressure 40, and when it is dissolved, it becomes 32. It becomes 32 by 40. It must be 8 by 40. Must be 0.2. 1 second. Mole fraction of A in the solution, it must be 0.8 or 0.2. The vapor pressure of the liquid in a solution with the liquid B is 32, and mole fraction of A in this solution, if it obeys Rolle's law, is 0.8, right? What is this simple logic is, PA will be equal to P naught A XA. What is PA? 32. What is P0A? 40 into XA. So XA is equal to 0.8. XA is equal to 0.8. Next question. A complex of iron cyanide is 100% ionized if its elevation in the boiling point is 2.08 and Kb is equal to 0.52, then the complex is see here it is 100% ionized. What we have to find? I value. What we have to find here? High value delta TB or delta TF. Delta TB is equal to I into Kb into M. I into Kb into M. IB into Kb into M. Now I is equal to delta TB by Kb into M, because M happens to be 1. What is delta TB? 2.08. What is Kb value? 0.52. So I value is equal to 4. Now what is the point? Alpha is equal to 1. Alpha is equal to I minus 1 by n minus 1. Alpha is equal to 1, and this is I is equal to 1. 4 minus 1 by n minus 1. So n minus 1 value must be 3. That is, n value must be 4. When we get the n value as 4 in the option 1, then K3FeCN6, when K3FeCN6 ionizes, we get 3 moles of K plus, 1 mole of ferrocyanide ion, FeCN6 ion. So total of 4 ions will be produced when K3FeCN6 is dissolved. So option 1 is the answer, because what is missing here? We got the alpha value 100%, we got the I value, we don't know the n value. So n must be 4. When we get n as 4, only when the complex K3FeCN6 is dissolved in water, we get the n value as 4. Next question. Moles of K2SO4 to be dissolved in 12 moles of water to lower the vapor pressure by 10 mm Hg at a temperature. So P0 minus Ps by P0 is equal to N1 by N1 plus N2. Now what is this? 10 by 50 N1 by N1 plus 12. Solving N1 is equal to 3. Option 1. It's direct Raoult's law application. Next question. 1 mole of aqueous solution of an electrolyte of X3, what is 25% ionized. The boiling point of the solution is, let us first find the delta TB. What is delta TB? Delta TB is equal to I into Kb into M. What is the I value? Alpha is equal to I minus 1 by n minus 1. What is alpha value? 0.25. I minus 1. What is the n value? When X3 is dissolved in water, we get 5 moles of ion. So n value is 5. 5 minus 1. So I value is 2. Now what is delta TB value? 2 into 0.52 into 1. into 1, it is 1.04. Delta TB is equal to 1.04, and boiling point of the solution will be equal to TB is equal to T naught B plus delta TB, because delta TB is equal to TB minus T naught B. What is T naught B? 373 plus 1.04, 374.04. Next question. In winter season, at some places the temperature falls to minus 0.36 degrees centigrade. The amount of ethylene glycol to be added to 300 grams of water to avoid the freezing. So here delta TB is equal to delta TF is equal to Kf into M, assuming the solute to be in order to avoid the freezing of the water. What to avoid the freezing of the water, what we are going to add? Ethylene glycol. Ethylene glycol is a non-electrolyte. So I is equal to 1. For water, Kf value will be equal to 1.86. 1.86. Now coming to the what is delta TF value? We must prevent 0.36. What is Kf value? 1.86. And into W1, what is the molecular weight of the ethylene glycol? Ethylene glycol is CH2OH. It is 62. It is a 62, and 1000 by 300. 1000 by 300. So calculating the W1 will be around 36 grams or 3.6 grams. I'm sorry. Thank you. We'll continue in the next class.